Today we are going to look at the removable and irremovable discontinuity. First of all, you have to first understand what the term discontinuity means, and when the function is discontinuous, you have to first understand that keyword. Discontinuity means when the function is easy, or when the function is expressed on the graph and it appears to be broken. For example, if you plot your graph and it appears to be like this, come stop together and then it continues like that. This graph is said to be discontinuous, and if the graph that's the y-axis to the x-axis, but if you plot the function on the graph and your graph or the curve looks like that, this is a continuous function. It belongs in the continuity, which is this continuity. So we see here our curve is broken and later it goes on up. But here, the moment you put the mark down and start plotting, it goes on till you are finished. This shows the continuity, while this shows the discontinuity. And in the discontinuity, we have the removable continuity and the irremovable discontinuity. Then let's first talk about the removable discontinuity. The removable discontinuity occurs when the limit of the function exists but at a certain point. And you can give an example if the function is undefined at the point that shows it belongs in the removable. And it naturally can be different at some point. So at a given point it can be different, and at certain points that can be undefined. When we talk about a function being undefined, this is what we mean. If you have, for example, if you have a function f of x equaling to x squared plus 1, let it be like that, over x squared minus 1. For this function to be undefined, we know very properly, a fraction to be undefined, the denominator must be equal to 0. That means if this is 0, for example, let's assume that our x is equal to 1. And if you put here 1, you're going to have 1 squared plus 1, which is 2. And then 1 minus 1, which is 0. This one, this is what we talk about if we mean the function is undefined. Okay, all are the same thing. Now let's talk about the examples of the removable discontinuity. The examples under the removable discontinuity. And we're going to start with our example number 1, which is f of x equaling to x squared plus 1. So let it be x squared minus 1 over x minus 1. Let's start with that as our first example. If you look at this equation as for the x squared minus 1, it shows you that this is a difference of two squares, which is x squared minus 1 is the same as x plus 1 into x minus 1. Then you come and put this in our function, which is f of x equal to x plus 1, x minus 1. We divide by x minus 1. When you look at this function, you have the two factors that can cancel, which is x minus 1 and x minus 1. If we cancel these, or if you take them out, this is what I am thinking about. We are going to start with f of x, which is x plus 1. But for this x, since we take the removable discontinuity can occur if the denominator is equal to 0, we are going to come here and first find the x value for the function to be undefined. Let our denominator, which is x minus 1, equal to 0, and x is equal to 1. That means at a point where x equals 1, this function is under the removable discontinuity. But again, we can remove this discontinuity. For example, you look here. This discontinuity can be removed. So that discontinuity can leave a hole in your graph as we saw in the first expression of the graph. But if we come and use this function over x, which equals to x plus 1, let us take points like 1. You have said yes. So this function at a point 1, if you just put here when it's like this, it will be undefined. But if we put here and find the function of 1, we will find that 1 plus 1 and this equals to 2. That means this same function, which is the f of x, equals to x squared minus 1 over x minus 1. This same function at the point of 1 with 1 as our x value and 2 as our y value, this function will have no the removable discontinuity. Then therefore at x, which is 1 and 2, the discontinuity is no longer existing. At that point, which is 1, 2, the discontinuity is no longer existing, and here it will fall in the continuous function. And here we can see redefining the function. That's our example number 1. Let's see example number 2. Example number 2 is going to be f of x, which is equal to x squared minus 9 over x minus 3 over x. X minus 3. But here we take the difference of 2 squares. Then we classify 2 factors. Then we have x minus 3. Sorry. We have x minus 3 times x plus 3. Still in our function, we get to x minus 3, x plus 3 over our x minus 3. But since we said that discontinuity for the removable is when the function is undefined, we are going to equal our denominator to be equal to 0, where we find that our x value is 3. If you come here in this function, let's look here. For f of 3, we find 3 minus 3 times 3 plus 3 divided by 3 minus 3. This gives you 0. 0 times here 6, which is 0 over 0. And this is divided since our denominator is 0. Now let's come here and proceed. We're going to redefine this. This is redefined as the limit of x tends to 3. We are going to have our f of x being equal to this one which wasn't passed out, and that is the x2 plus 3. Then if you find the f of 3, you will find that the f of 3 equals to 3 plus 3, and that is 6. That means this is the removable discontinuity. And this which does not pass out is what we call the irremovable discontinuity. But if we redefine it, you find out f of 3 when it is equal to 6. Here I think undefined. Then we will say that the function f of x equal to x squared minus 9 over x minus 3 at a point of 3, 6. The discontinuity no longer exists. That's all what I have concerning the removable and irremovable discontinuity. Thanks for following.